Right, class. Um, let's start looking at this section on reaction of saturated heterocycles with uh, with the nucleophiles. And in this case, I want to look at a specific example, especially when you're dealing with a three-member ring. Though what you are discussing can apply to a four-member ring, and a five-member ring, and even a six-member ring. So these reactions, we are going to split them into two aspects. Uh, are you dealing with acidic medium, or are you dealing with basic medium? If we're talking about an acidic medium, it means that you've got a pH paper and you've inserted it, and the pH is going to be less than 7, or if it was blue, it's going to turn pink. And in this case, if it is the basic, if the litmus paper was what was red or blue, then it's going to turn pink. Or if it will be a universal indicator paper, then which is usually yellow, then I think it's going to turn usually dark blue and the rest. The more blue it is, then the more basic it is. Yeah. Yeah, so what you need to know is that in, in the acidic medium, the nucleophiles are going to be weak. Why are the nucleophiles weak? What if you are to put a nucleophile like sodium hydroxide in a solution in which there is something like hydrochloric acid, or maybe let's say hydrochloric acid? What's going to happen is that the hydroxide which you put into the medium, rather than it react with your heterocycle, what's going to happen is that there will be a very fast neutralization reaction in which the hydroxide is going to react with the acidic medium, in this case something like hydrochloric acid, and it's going to be quenched to form water plus the chloride. So if you're going to put in a strong base in an acidic medium, what's going to happen is that the strong base will be protonated to form a weak nucleophile. So that in this case, if you had hydroxide, it's going to be quenched to be water. So in an acidic medium, you're dealing with weak nucleophiles like maybe methanol or maybe water, something like that, very weak nucleophiles. Please know that. And then if you're dealing with basic mediums, then now you can be able to have those things like the hydroxide, methoxide, ethoxide, amide, and the rest. Those are uh, strong what? Bases. They can exist in uh, strong nucleophiles. They can exist in the basic medium. Yeah. So the thing is, okay. So that's something to note. In the acidic medium, you have weak nucleophiles. In the basic medium, you have strong nucleophiles. And then, in the acidic medium, you're going to have positive charges which are going to be formed, which are going to be stabilized by the acidic medium. So that in this case, you're going to be forming carbocations, and carbocations are usually formed by SN1. It means that a bond is going to break, and you're going to form a stable carbocation. You know that methyl carbocations and primary carbocations do not form in acidic medium because they are not stable. Primary carbocations are not going to form. Methyl cations are not going to form. Yeah. So for you to form, so that in this case we'll be talking about secondary and tertiary carbocations. So the more sterically hindered the center is, then you know, hey, that's the point in which the ring is going to break up if you're going to be talking about a reaction in acidic medium. Yeah. So the ring is going to open up to form a stable carbocation, right? The ring is going to open up to form a stable uh, carbocation. Carbocation, I'm talking about a cation which is a positive charge and it is based on carbon. Yeah. If it's just a normal cation like sodium and the rest, they're just called cations. But if the cation will be based on carbon, then it will be called a carbocation. Now, when you're dealing with basic media, I'm putting side by side so that we can be able to compare. When you're dealing with basic medium, then the base will be able to undertake, will be able to do an SN2 type of a reaction in which the nucleophile is attacking one side and then the leaving group is leaving the other side. And you're going to look at those type of reactions, yeah? So for you to have an SN2 type of reaction, an SN2 cannot take place in a tertiary situation because there will be steric hindrance. So the SN2 requires the least hindered carbon atom for it to react, the least hindered carbon atom. And then the ring is going to open up to form anions, which is different from the previous one in which the ring is going to open up to form a stable carbocation. So so just to mention something about the basic conditions, um, uh, just as with the acidic medium, in the basic medium, the solvent is polar. So that in this case, you'll be talking about a base like water or the alcohol like ethanol, methanol. But what I may need to mention is if you're doing research in which you're talking about use of a certain nucleophile, like in this case, if you're talking about the base being hydroxide, if that's the one which you're going to use, if you're going to use a solvent like methanol, then the hydroxide, in addition to it acting as a nucleophile, it can also deprotonate your solvent, which in this case is methanol, to form a methoxide, which so that you are not going to get rather than you having a hydroxide, you're also going to have a methoxide, and that one may produce different products. So so if you are going to have a hydroxide, please use water, H2O, as the solvent, so that if the hydroxide will deprotonate the solvent like water, it's going to generate another hydroxide. If you're going to use methoxide, then use methanol, so that even if the methoxide is going to deprotonate the solvent like methanol, it's going to generate what? Another methoxide. If you're going to use ethoxide as a solvent, use ethanol as a solvent, so that if it's going to deprotonate the solvent ethanol, it's going to generate a new ethoxide. Yeah. So for the base, the solvent that you use matters. Okay. So I think I'm just going to pause there, and then I think we'll look at a specific example. Let's say like in acidic medium. Yeah? Once again, you're looking at a three-membered ring, though the reaction can apply to a 4, 5, or 6-membered ring. Okay. So I'm just going to pause, and then we'll continue after that. Okay. All right, class. Let's continue. I hope the top part can also be seen quite well. So what I've done is to separate this reaction. It may be a bit looking clumped, but I'm putting side by side so that you can look at the reactions to be able to see how it takes place either under basic conditions or under acidic conditions. So in this case, you say you have the basic conditions in which you've got the hydroxide as your base. So sodium hydroxide is a solid. So you need to dissolve it in the solvent in an appropriate solvent, which in this case is water. In this case, you're going to use methanol as your solvent, and it will be in sulfuric acid. It means that the conditions are going to be strongly acidic. Yeah. So please remember what I said. In basic medium, you've got a strong base. In acidic medium, you've got weak nucleophiles or weak base. Let me say, okay, in this case, you're dealing with, rather than to call it a base, in this case it's a what? Okay, a base is also a nucleophile. Because in this case it is attacking, in this case you're dealing with what? Uh, with the hydroxide being the nucleophile, yeah? Yeah, so that in this case it is the nucleophile. Um, so it being negative, it's looking for a center which is has got a partial positive charge. Now in this case, you say oxygen is electronegative. So you've got two carbon atoms which have got okay. If I may put here, this is delta plus, delta minus. So this is delta plus and this delta plus as a result of the oxygen pulling electrons. And then you're going to see, hey, uh, which of these two carbons can be attacked? This carbon is sterically hindered, has got a methyl group, has got two methyl groups, so they are quite bulky around it. Now this one has got only two small atoms, hydrogen and hydrogen. So this one is least hindered, and it will be the atom which will be attacked by your nucleophile. So the nucleophile is going to attack this carbon atom. When you see a curly arrow, based on also what we show about the orbitals, you're forming a bond between your oxygen and your carbon. Yeah. So this oxygen has got three lone pairs. So one of the lone pairs has got two electrons, which will be used for forming a covalent bond. So as a result of the formation of that one, this oxygen, the number of lone pairs will drop from three lone pairs to two lone pairs. So now you're going to be forming a bond between your oxygen and your carbon. Now, oxygen has got one bond, so that will be negatively charged. This carbon has got one, two, three, four. So if you're going to form a bond there, then one of the bonds on the carbon has to break. So the one which will be breaking will be the one in which the electrons will be going towards the electronegative uh, atom. So the electrons will not go to the carbon, but they will go to the electronegative atom, which is oxygen. All right? So, so as a result of this oxygen hydroxide attacking here, so you're forming a bond between your oxygen and your carbon, which is showing here. And then as a result of that, the bond between your oxygen and the carbon is going to break. So in this structure here, this carbon and this carbon still remains there, but then this carbon will now still contain the bond with the oxygen, but now the bond between your carbon and the oxygen has broken. So this was the initial bond between your carbon and oxygen, but it has now broken. So you'll end up forming your alkoxide. Alkoxides, they form in basic medium. So please know that if you're going to have an acidic medium, like sulfuric acid and maybe another acid, and then you say, hey, under those conditions you are forming things like hydroxide and alkoxide and the rest, please know that your mechanism is wrong. Yeah, because uh, because the acidic medium is going to quench any of those things like the alkoxide and the rest, yeah? So that in acidic medium, you're going to have weak nucleophiles. So once you formed your alkoxide, the alkoxide is going to deprotonate the solvent to form the product. So that in this case, the alkoxide is going to take up a proton from the solvent, which is in this case is water, to form the alcohol as the product. Let me see, plus OH, yeah, hydroxide, yeah, let me say plus the hydroxide. So that's what will be formed under basic conditions. Then under acidic conditions, in this case I've just chosen a solvent like methanol, and in sulfuric acid, yeah. So that in this case, uh, the first step is usually what? The protonation of the heteroatom. Why is that one important? What if I'm going to say what if I'm going to, okay, the thing is, what if you are to have uh, the ring trying to open up, and and the heteroatom is not uh, is not protonated. Um, you will end up having a what? A negative charge on the on the heteroatom, which is not correct. But in this case, if initially it is protonated, then as a result of the bond between your carbon and your oxygen opening up, then the heteroatom is going to attain a, a neutral charge. So ensure that before you react to before you actually form your carbocation, then the heteroatom, in this case is oxygen, is going to do what? Is going to protonate. So if it's going to protonate, you're going to get your oxygen being positively charged. And then I think you are aware that the a negative atom, like like let me say an electronegative element, like what? Like oxygen does not like having a positive charge, so it would rather have a negative charge than a positive charge. So as a result of the positive charge being on oxygen, then one of the bonds is going to break, so that the positive charge would reside on the electropositive. Uh, Let me say carbon is relatively electropositive than the oxygen. So the bond here, you see that the bond which will be breaking will be the one which will result in the stable carbocation. So the most sterically hindered, or the most substituted one. So it's going to give the tertiary carbocation, and the alkyl groups, they stabilize your carbocations by donating electrons. That one I think you've learned in lower classes. So once you form your carbocation, the carbocation will not form this side, because that will give a primary carbocation, which cannot form. You can only form a secondary or a tertiary, but not a primary carbocation. So once you formed your carbocation, then it will be attacked by your solvent, which you have in solution, which in this case is methanol. So the oxygen, the methanol has got two lone pairs. So one of the lone pairs will be used in forming the covalent bond between your oxygen and your carbon. So you can see that this oxygen does not has got a positive charge. One of the lone pairs has been used in forming the bond between your oxygen and your positive charge. So the final product will be what? One of the positive this oxygen has got a positive has got a hydrogen, which is going to fall off as a the hydrogen is going to fall off as a proton. So it means that this bond is going to break, and the electrons will end up pointing that positive charge to form your what? To form your to form to form your product, uh, which will be the one shown at the bottom. Yeah. So that one plus H plus, yeah. So that will be the product. One thing you need to see is that under acidic under basic condition, it is the carbon which is least hindered, which is attacked. But under acidic conditions, it is the carbon which is sterically hindered, which is attacked. So in other words, you're going to get different products. Okay. So I really hope you've enjoyed this explanation for this heterocycle. I've given an example of a three-membered heterocycle reacting either under acidic or under basic conditions. I think I may have stood on the way, but I hope you can now be able to see. The good thing about the videos is that you can be able to pause and then rewind in case maybe the explanation you needed to get a second explanation for that. Yeah. So I think so that's the much I'll talk about this saturated heterocycle reacting under basic or under acidic conditions. Okay. So thank you very much.